Okay. Now recap what we learned previously. We are now looking at very strict line of motion. And every time when you solve question in dynamic question, you need to have your reference, where is your origin, O, we reference as O, and then we always have a positive direction, either to the left, to the right, to the go up or go down, or coming out from the screen, right? I would recommend that for this module, you always follow the motion. This means if the object is moving to the right, then right is positive. Okay, but traditionally, you follow the x-axis. If x-axis move to the right, you get positive. Moving up is positive, and moving out from the screen is positive. Okay, so we have axis system, and then where is positive, where is negative. And then throughout this module, you are dealing with 4 parameters, which is the position, we label as S, right? Position. And then we deal with velocity, V, and we deal with acceleration. And one more that link your position, velocity, and acceleration is the time, T. Okay, so these 4 is, you'll see these 4 parameters throughout the whole semester. Okay, so remember, and all these, they are vector. What I mean by vector? We have magnitude and direction. So they are vector. They are no longer a scalar. Like for example, velocity scalar is speed. And previous lecture, I show you the differences between speed calculation and velocity calculation. Right? Average speed and average calculation, there is a difference. Okay, but throughout this module, we are focusing on vector. Okay, now the next thing that we learned previously is that position, we derive something called displacement, delta S, which is take the final position minus the original position. Again, this is vector. In previous slides, I show you already. Moving, if the final position is on the left-hand side, then you will get negative sign for displacement, because all the direction to the right is positive. If we look at this free body diagram, then your displacement is a vector displacement. If the final location is opposite or different from the original motion, then you get negative sign. Okay. Now in this module, positive, negative means something. So be sure of the direction. Because you are dealing with dynamics. Dynamics means something that's moving. So you need to answer where is the initial position, where is the final position. Then there is a derivation for velocity and acceleration. To get velocity, you need to have time differentiation of your displacement or your position or displacement. Okay, V equal to ds dt. And this one is a differentiation, it's not a division. You don't take the top value divided by bottom value. No, this is a time differentiation. It's a differentiation equation. So you need to recall back what you learned in your differentiation, integration, and so on. What I mean by acceleration? Acceleration, you link with velocity. So every time you do calculation for V in your free body diagram, you will see you need to label S and so on, S and time. And if you're calculating acceleration, you are taking velocity differentiation with time. So in your free body diagram, you will put inside velocity. Okay, so velocity, your free body diagram, you're seeing S vector, but when you look at acceleration, you look at velocity vector. They are different vector. So don't confuse, don't see your free body diagram as the same thing. Although I've drawn only one arrow on the whiteboard here, but if you see at a different dimension or different parameter, they are the different things. Try to like see it in the different angle. All right. Now, previous lecture also I show you acceleration can also written in the terms of displacement. How? You see this one if as you learn in the differentiation mathematics class, you take dv dt out and then you substitute v inside here. You'll get double differentiation. What is v? V is this definition, ds dt. So dt actually is a double differentiation of your displacement. So d square s dt square. This is what you learned in our previous lecture. Okay, so as you learn this one, then today we'll derive equation for what you learn in your SPM. We'll use that for projectile. We'll use this one as your base to derive more and more equation. Okay, now you have 4 equations. We did this one, this one, this one, and this one. You have 4 important equations. Right. So let's continue our lecture as we move on. Okay. Now this is what you learn up to last class. Okay, the PowerPoint, the screen that you see here is a bit bluish, but the one you see in the PowerPoint in the canvas later, it will be very colorful. So it's due to the hardware things. All right. Now we are looking here at there's a marking there. If the velocity is constant, acceleration is 0. Are you able to understand this statement? Yeah. So what does it mean? If your velocity is constant, you are differentiating a constant value, like what you learned in your mathematics class. If you differentiate some constant value, you get 0. Okay. So for example, y equal to 3. dy dx, you will get 0. Okay. So later you will see graph. This is y, this is x. If your y is 3, dy dx is actually a gradient of your graph. Straight line, your gradient is 0. Okay, now we move forward. Today we are now in rectilinear motion and continuous motion. Means we assume the particles, we are now in particles. Particles continue to move along the straight line. All right. Now, again, you draw a straight line and the particles moving. You have your position. You have your, all right. So you know that instantaneous velocity is a ds dt with a time differential of your displacement or your position, right? So acceleration a equal to dv dt, like what we covered 5 minutes ago. Now, are you able to relate time differential dt between velocity and acceleration? Meaning, it does take this statement actually tell you to the top equation is that velocity in terms of displacement and time. The second equation here is acceleration, velocity, and time. This statement here on the screen here is actually asks you to combine to see at the time dimension what is the relationship between velocity and acceleration. Meaning you freeze the time and then you see what happened to the two vector acceleration and velocity. So what you do, actually, you are rearranging the equation. You pull the dt to the left. You pull your dt to the left. You pull the v, replace the dt position. Here also same. You rearrange the equation, pull the dt, and then pull the a down. So you have dt equal to something, dt equal to something. So these two are the same thing. You combine them together, you arrive at a new equation. Okay, this is the mathematics steps. You move around the parameter. Okay, you move the v down, you move the a down. So they basically you are equaling the dt, the time differential, meaning you are looking at the time dimension, right? So when you have the same thing, what you do, you equal them together, you rearrange them. That's what you see on the screen here. ds over v equal to dv over a. But throughout the module, we don't like this fractional form. We don't like this fractional form. We like linear form. Means in the straight line kind of presentation. What do? You move your a to the left. You move your v to the right. Then you get a linear form that show you as on the screen here. From this equation, you get a ds equal to v dv. So today you learn a new equation where you combine these two. You combine v definition, a definition, you get new equation by equaling the dt. You get a ds equal to v dv. What does it mean? This one, every time you see this kind of form, you need to recall integration. Something ds, you need to put in the integration. Something dv, you need to add in the integration sign. So actually, the next step of this one is integration. Okay, makes sense. All right. So the next step, we're going to derive equation for your kinematics motion, where you learn in your, where you use it for calculating projectile question. Means you throw something else, then what will it be? You try to predict the n location or the n velocity or n acceleration at certain time, right? Okay. So this one we already covered. So just now we arrive at this equation. Maybe I go too fast. Okay, this one. Okay. Now another thing is that we try to derive another equation, which is a equal to dv dt, as we covered last lecture. Definition of acceleration equal to time differentiation of your velocity. Same thing, you move dt on the right hand side, move to the left. Because this is a fractional form. We don't like fractional form, we like linear form. So we move dt to the left, we'll get dv equal to a dt. So same thing, when you see something dv, something dt or the d form, you like to add in the integration. So what you do, velocity in a function of time, you add in the integration form. So on the left hand side, actually you are you're integrating the velocity, and the right hand side, you're integrating the acceleration in terms of time. So actually they are the same dimension, right? Now what is the unit for velocity? Meter over second. What is the unit after you integrate here? You actually take acceleration. Acceleration is meter over second square. So you take acceleration multiply by time. So actually you are meter over second square. You multiply by time with the second, the time dimension, you're still arriving at meter per second. So the whole equation, you are balancing the equation. Okay, so, and this equation, I need to highlight this one. When you use this kind of integration, we are assuming you have a constant acceleration. When you use this kind of integration, you are having a constant acceleration, a sub c, right? So you know how to do integration, right? This side is what? V minus VO. You take the top value, top limit minus the lower limit. This side you get V minus V0 or V0. This side Since this is a constant, what you do with the constant integration, you pull the constant value out. You pull out, this one become 1. When you're integrating 1, you take the top value minus the bottom value. Makes sense? Okay, so you arrive at this equation. Anyone, you get this one, or you need me to write you the equation? Can? Okay, so stop me if you are missing something or you don't understand something. So basically from the step here to here actually is a expansion, or you do your integration steps. You arrive at this one. Okay, on the left hand side, v minus v0 equal to ACT, because you bracket t minus 0. Okay, so you rearrange, you arrive at v equal to v0 plus ACT. You see this equation before in your physics class. In my class, I call them as Newton equation or motion equation. Okay, the first one we derived this morning. It is v equal to v0 plus ACT, again constant for your acceleration. You can only use this equation when you have constant acceleration. Okay, we move to the next one. Okay, now the first equation we derive using acceleration definition. Okay, from here. Okay, the second thing, we use velocity. Same. Velocity definition is the time differentiation of your displacement. Same, we don't like function form. We rewrite in a linear form. So you pull your dt to the left, ds. Same, we don't like to see ds or d something. We add in the integration form in front. Basically, you continue to do the integration steps. You'll get a new equation like this one. S as O means initial position equal to time dt. So recall back the integration. It depends on your ds here. If this one is s, your limit is s. If your other side is dt, your limit for integration is the time. So don't confuse displacement and your time. Some of you are weak in your integration, is okay, but try to catch up. So some of you are confused. Hey, what value should I use for my limit? You're referring to the d something. If this dt, then you refer to time. If you refer to s, you refer to that. All right. Now, if you do integration, again, if you see something blank here, it means 1. It's not 0. So this model is very sensitive. If it's 0, then 0. If it's 1, it's 1. But normally, you see 1 here. Don't assume nothing here is 0. No. Something blank means 1 in the integration. So this side, you arrive at s minus s0. Again, velocity here. Okay, velocity here. You need to do a little bit of modification in the calculation. Why? Why we need to do modification? Again, it is different from the statics. Static, your velocity is constant, but dynamic velocity is not constant. So you cannot assume this one as constant value. Don't assume this one in dynamics. This one velocity constant. So every time you see v, you need to think of what is the definition of velocity, and then you substitute. For example, just now we derived v equal to v0 plus ACT. In the previous slides, 5 minutes ago, we derived this one. What you do, you substitute this one, put inside here. You are seeing it in terms of acceleration, because we assume acceleration is constant. Okay. Right. So when acceleration is constant, let's say 10 meter per second square. What does it mean? You look at the particles. This one may be 0 meter per second or 0 second. But seconds, when first second, it becomes 10 meter per second. This one. But this one, velocity at 2 seconds may be changed already. It's not 10 meter per second. So that's why the velocity keep changing in dynamics. So this, I need to highlight this one. Okay, when you substitute that one, is also test your integration skill. You just substitute inside there. Let me see if I give you the answer. Okay. So you just substitute this one inside here. What you do, basically, you have two equation here, two integration steps. One, you differentiate VO. One, you integrate AP dimension. Okay, there are two integration steps here. All right. So here, you know that this is 1. So when you have 1, you take S minus S0. You have the left-hand side. Here, you have two steps. One is integrate VO dt. VO is what? Is value. Right? So you get VO, VO bracket T minus T plus AC is constant, you pull out, and then you bracket T minus T0. Then you rearrange. You get this answer. Okay, you need me to write you the derivation. Okay, maybe I write you the equation. Maybe some of you still stuck at your integration. This one. So how you arrive at that one? Okay. So this one you have SO, S, E, O, T. So this side is 1. So here you S minus S0. Here you see it as two integration steps. Okay. So you do the first one. So here is V dt. So you have VO T minus 0. Here you continue that one. A, C you pull out. You are integrating the time. So what you do, for example, you're integrating the x dx, for example. It will become, let's say this is n. The equation will be xn plus 1 divided by n plus 1 and constant value. Right? So if you have a limit, then you don't have the C. Right? If you have value on the limit, you don't have the C form. So you take this thing. So you have A you pull out already. So you only have T, right? T power something. This one is 1. So what you do by that, 1 plus 1 divided by 1 plus 1. Because this one have limit, so you're actually putting the limit. So at the end, VOT plus this one, AC T square divided by 2. That's why you see there's a half here. Okay. Yeah. So this is how you derive. But I always like, it depends. Sometimes you, if you're lazy, you can just put delta S there. So second equation, I'm a bit lazy, so I put delta S. Delta S means S minus S0. It's a change of location. Right? Okay, now this is vector. So when it comes to question, don't think like you did in your statics. It's a refer to the origin and the last position. It's the last position is opposite the direction, means you get negative. So The second equation you get is VOT plus half AT squared. Again, constant acceleration. Makes sense, huh? Okay. All right. Now we have derived two equations already. So these two also you're very familiar in your physics class when you do your projectile kind of question. So we move on, huh? Move on. All right. Now previously, okay, so what we do is that we use the definition of acceleration. Definition of acceleration, we derive the first equation. We use the definition of velocity, we derive the second one. Then the third one, we use this one. Okay, we use this one. So just now, we derive equation A ds equal to v dv just now. This one. So what can we do with this one? So what we do is that we add in the integration sign only to get the third equation. Okay, to get the third equation of the Newton motion equation. That is my own definition, my own calling. You don't find this one in the textbook. So every time in our class, when I mention use the Newton motion equation, means something that I write on this here. This. Okay. And acceleration is constant. When you use a Newton motion equation, acceleration is constant. So meaning you read the question, you read, then you tell you velocity remain constant. It means acceleration is constant. Because acceleration is zero, right? If your velocity is constant, your acceleration is zero. So zero, you can use this equation, you cancel out the acceleration, right? Or you have a displacement here. You're given time. You're given the time equation. You're given the position equation. You can calculate the A, right? Okay, later I'll give you the equation. So same, you do your integration steps from the screen here. You integrate your A with S because your ds, so your limit in the integration is displacement or position, right? Position at the end minus the position at the initial, right? So n minus initial. So you get the bracket here. And the same for velocity on the right. So you are integrating the v, like what I showed you on the whiteboard just now. You're integrating the x. Right? So you're integrating the same thing. Remember to use the procedure where v above the v here is 1. So when you're integrating the same parameter, like example what I write on the whiteboard there, x. So here you add 1, v 1 plus 1 divided by 1 plus 1. So you get half. Sense, so don't get stuck here, right? Then you bracket, then you do the substitution. So when substitute, you have a v here. This substitution, this substitution. So then you tidy up the equation, you will get this equation. Meaning, again, the way we solve, we don't like fraction value. We pull the 2 to the front, to the left, because half is sometimes very troublesome, right? So we pull the 2 to the left, we get 2ac s minus s 0 equal to v squared minus v initial squared. This is after you substitute the value here. Then we rearrange. Rearrange in final velocity. The third equation, v squared equal to v naught squared plus 2ac. And again, I lazy, I put delta s. Delta means change of position. So this 3 equation is important for your test 1, question 1 kind of question, or maybe question 2, and final exam question 1 kind of question. Okay, yeah. So Yeah, don't worry. All the thing that you see is the PowerPoint slide you get in the Canvas. So you like, okay. Only the thing I write on whiteboard is a recap, help you to learn better. Okay. So any questions so far for this the three derivation of equation? I think you see this one before in your physics class, in your SPM, or in your secondary school physics class. Okay. Now in this module, question one, some question you need to derive the steps here. Some question, right? Some question. Right. But for question one, for your test one, normally you just need to memorize these three, and then you apply. The only condition you are applying these three is constant acceleration. If your acceleration is not constant, you cannot use these three Newton motion equation. Yeah, that's the only things that you need to take. Okay, let's look at this example. Okay, now we apply. We already conclude the first section of the chapter one. So the car on the left moves in the straight line, right? On the left moves in the straight line, such as for a short time velocity defined by the equation. Now, this is the special characteristics of engine dynamics. You don't see this kind of velocity in statics. In statics, you straight away give you one value, right? So again, if you see this kind of question, it means you're in chapter one. You're in chapter one kind of question. You see velocity equal to one equation, and then you see the something move in straight line, means it's a chapter one kind of question. Chapter one is move in a rectilinear motion. Okay. Then determine position and acceleration when time is 3 seconds. When t equal to 0, s equal to 0, it gives you the initial position. So it asks you to find the position and acceleration when there's a certain time. So how you solve? How you solve? So you draw your free body diagram, right? So again, free body diagram, you can represent with the dot in your free body diagram for chapter one. But when it comes to rigid body, you cannot represent with the dot anymore. Means after we go into rigid body later, you cannot use dot anymore. Okay, so for first one, what you do, you draw a dot, and then you draw your free body diagram. As a habit, I always follow the motion. When every time I draw my axis, I will put where is my positive. In this case, it moved to the right. Right, so I label as initial O, and then the information I have is velocity equal 0.6 t plus t. Again, unit is important, meter over second. And move. You need to find after 3 seconds what happened to the position and acceleration at that t equal to 3. You need to find t equal to 3 over here. Okay. So when the car move in a straight line after a certain period of time, in this case t equal to 3, you have your displacement, right? And then you need to find acceleration and velocity. So start with your coordinate system. Follow the motion as what I recommend. So in this case, the car moves to the right, so right is positive. Okay. Position is given. Again, how you define position for dynamics? Since the earlier class, I introduced these four members: position, velocity, acceleration, and time. This will define your dynamic position. So it gives you the velocity equation. So You know that the definition of velocity is a time differentiation of your displacement. So what you do, you have a velocity equation. You want to find the position. What you do, you rearrange this differentiation equation into integration equation. How? You move your dt to the left. Move your dt to the left. You see d something, you add in the integration sign. Then from there, you're able to find your displacement equation. Yeah. So first steps, when you solve dynamic question, draw free body diagram, know where the object is moving, where is positive, where is negative, and then look for the position information. It can be position, it can be velocity, it can be acceleration, it can be time. So you have four kind of equation for you to look at. Okay. So basically, when you solve question, you write this equation on your answer sheet. You write this. You write this, and this one. Basically, you'll get 3 marks. Like for example, here maybe 2 marks here, another 2 marks or 3 marks here. By writing the general equation, you have some marks there. Okay, and if even you draw the things, also have marks. Okay, so it's very hard to fail for this module. Okay, so you integrate ds equal to v dv from the velocity definition. Then you do your calculation. Okay, you do your calculation. So again, this is a dynamic classes. It's not static, so your velocity is not constant value. Especially for this example 1, your velocity is in the what form? So if you plot graph, you have a few type of graph. You have a linear graph. Give you y equal to mx plus c. It is a linear graph. You have quadratic graph. Y equal to ax squared plus bx plus c. Okay. When your a is positive, you get a smiling graph. If your a is negative, you get a sad face. Means the curve is smile or sad, right? And the third one is polynomial. Y equal to ax cubed or something more than 3, bx squared plus c, and so on. Okay. So in this module, the most I ask you is polynomial, but in most cases, I will stop at quadratic equation. Okay. So these are just a recap of mathematics. All right. So back to our tutorial question here. You substitute your v inside there. And the next step, because you're seeing d something on the left, d something on the right, you just add in the symbol of integration and you do the mathematics part to derive a new equation for your displacement. Okay, so are you able to get the general equation for this question? Try to do it. Try to derive the position equation. See if you're able to get. Okay, I'll show you the next steps. You put in the integration sign. Again, don't miss out the 1, or you can leave it blank, but don't assume it's 0, it's 1. Okay, so integrate s on the left, integrate f on the right. So on the left, basically you get s minus 0. On the right, basically you have two components here. You can break into 2 integration equation here. So you can do the first one, then plus the second one. So the first one is 0.6. You pull out the constant. Then because of this t square, same, use this equation. integrate s. So x power n. So your answer for integration is x power n plus 1. So here is t exponential 2. So you have t 2 plus 1 divided by 2 plus 1. And there's no constant value because you have the limit in the integration. So we can leave out the c. So you have the first one. Plus second integration, you have t here, t dt, same like what I write on the whiteboard, x. So t, again, on the top of t, you have 1, exponential 1. So you have t squared divided by 2. Then the rest is just rearranging the equation. You get, okay, you get the, it might seem complex, but if you follow the mathematics procedure, you will arrive at this equation. Okay, so it gives you the new definition for this example. Your displacement equation, now it becomes a polynomial equation. So it is 0.2 t squared plus 0.5 t squared kind of equation. The unit is meter. So you don't see this kind of presentation in statics. In dynamics, you see polynomial, you see quadratic equation and linear equation, right? So static, you only see the most is linear equation or constant value, right? But in dynamics, you are dealing with higher degree of equation, right? All right. Now, yeah, yes. 0.5 is 1 over 2. 1 over 2 is 0.5. Okay. But of course, you can put in a fraction form if you like fraction form. No problem. Okay. So the rest is just substitution because the question asks you position, right? So you substitute t over here, t equal 3, you get the answer for s. So what is the answer? If you press calculator, what's your answer for displacement or position? 9.9, huh? Okay, you get 9.9 meter. In this module, minimum decimal place is 2, maximum is 3 decimal place. Minimum 2 decimal place, maximum 3 decimal place. It depends on the accuracy of the question. All right. Any question for this one? Okay, next one is acceleration. Same. Acceleration. When you do acceleration, you look at the your cheat sheet there. Acceleration give you what? What is the definition of acceleration? Time differentiation of velocity. So you write this one in your answer. You pull out this one, a equal to dv dt. Then again, repeat the same procedure, dt to the left. Then you do integration. Then you substitute the answer. Okay. So v equal to something given you in the question already. Link velocity and acceleration with the definition of acceleration. V equal to a equal to dv dt. So you again, in this case, you just do differentiation. Okay, you do differentiation. dvd, this is a differentiation. So basically, you differentiate this equation. It's a dy dx kind of approach. This is your y. So dy dx. Okay, so this is x. Y and x. Okay. So when you differentiate time, so 0.6 p power 2, you move to the front. All the constant value you remain. So those exponential one, you move to the front, and then minus 1. So you get 1 plus t power 1 also have 1. 1 minus 1 is what? 0. x power 0 equal what? 1. Huh? It's not 0. This one, I see a lot of mistakes in the previous batch. When they power something 0, they were blank. They don't know how to continue already. Or some of it, even worse, they put 0. So they get the wrong answer for the final one. So again, this one, when you differentiate something, you get 1. The answer is 1, not 0. T, you differentiate t power 1. When you differentiate n minus 1, okay, the differentiation equation, y equal to dy equal to x power n, for example, dy dx, the general equation will be xn minus 1. Sorry, this one. It will be, you pull the n in front, x minus 1. Okay, this is the general equation for differentiation, meaning you pull the n in front, then you minus 1 this one. So there's these two is a general equation for, one is integration, one is differentiation. So you do the same, you arrive at this one. So acceleration, you arrive at one new equation, which is 1.2 t plus 1. So you substitute the time inside there, you find your acceleration. Acceleration equal to 4.6 meter over second square. All right. Now, how do I mark your answer in your assessment? For example, time, A equal to 4.6 meter per second. Let's say this is a 2 marks kind of answer. If you write A equal to 4.6 without the unit, you only get 2 marks. Sorry, you only get 1 marks, even though you get the correct value. Why? The unit is missing. Okay, so for all the answers, if you forget to put in the unit, you get 50% discount from the full marks. Okay, so unit is very important. Okay. So put a note there. Maybe this one might be, the color is not there, but if you download the PowerPoint slides from the Canvas, you see this one in red color, means it's very important. Formula for constant acceleration cannot be used. Means this Newton motion equation cannot be used to solve this question because acceleration is not constant. Your acceleration is this equation. It's not a constant value. It's a linear equation. So the Newton equation cannot be used. So this is just show you that when you can use Newton motion equation, when you cannot use. Okay, this is a very basic things. Okay, so we have a short break here. We continue maybe 9:05. Okay, 9:05 we continue. Okay, we stop here.